Concept B, we're going to move along to naming molecular compounds. We have some similar goals with this concept as we did with the last one, except we're focusing on molecular compounds. So we're going to be using the stock system again and applying Roman numerals when necessary. We're also going to use an older naming system, which applies prefixes. And then in class tomorrow, we're going to be interpreting these names to develop chemical formulas. So molecular formulas can be named in two ways. The first one we've already learned about when we talked about ionic compounds. So we're going to need to determine if we need a Roman numeral to represent the charge of the first atom written in the formula. Remember, in order to know the Roman numeral, we actually need to analyze the formula. So nitrogen in both A and B can take on multiple oxidation numbers, which is important because that's going to tell us that we need to then find a Roman numeral. So let me just change this to a pen. Oops. Go back to A and B. Here, oxygen, we know is -2. I have 3 of them, which is -6. If this needs to equal 0, this then is +6. I only have 1 nitrogen, so the entire +6 goes on to this nitrogen. So I'm going to have my nitrogen, the charge on the nitrogen, which is +6, so it'll be in a 1 to give me 6, and then oxygen goes to oxide. Here on this compound with the N2O5, each oxygen is -2, which means this is -10. +10 divided by 2 means in this compound, nitrogen takes on a +5 charge. So in this case, I would have nitrogen, oops, that should just be a V there, 5 oxide. So you can see the importance of, if I had only simply named these as nitrogen oxide, I wouldn't be able to differentiate between these two formulas, which is important and one of the reasons why we need to use the stock system. Here we have 2 other examples. Carbon and phosphorus both take on multiple positive oxidation numbers, so that's why we're going to need to use this. So my first one is carbon. And because, again, carbon has multiple oxidation numbers, I'm going to have to use chlorine to figure it out. Chlorine, when it's most electronegative one, written second, takes on a -1 charge like fluorine. I have 4 of them, so that means this is -4 to equal 0, which means this is +4 divided by the 1 carbon, so +4 divided by 1 means that this carbon has a +4 positive charge. So I'm going to represent that 4 over here with the Roman numeral, and then chlorine goes to chloride. All right, down here we have phosphorus, which has a multiple oxidation state. Okay, oxygen, again, is -2. -2 times 3 is -6. +6, because I want this to equal 0. This is a neutral compound. +6 divided by 2 is +3. So each phosphorus has a +3 charge, so I'm going to then show that in my name, and then oxygen goes to oxide. All right, so that's just a review of the stock system that we use for ionic compounds, and we can see we can also apply it to molecular compounds. Another naming system is an older method that we don't tend to use anymore, but it's important that you're aware of it because some common names use this, is the prefix method. So these prefixes are going to describe how many atoms of each element are found in a compound. So the number of atoms you can see here, 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, and 6 is hexa. Now, make sure you pay attention to these notes on the bottom. The prefix mono is never used for the first element, and the final O's or A's of a prefix are actually dropped when the element begins with a vowel. So oxygen, if there's only 1, we actually drop the O off of mono so that it can combine correctly with oxide in that case. So here are some examples of writing the prefix name. This first one I would name as phosphorus. I only have 1, so I'm not going to show the mono. And I have 5 chlorines, so that would be pentachloride. For this next example, same thing. I only have 1 to start for sulfur, so I just write sulfur as is with no mono prefix. The oxygen, though, I do have 3 of, so I'm going to have trioxide, so sulfur trioxide. Here I have sulfur with 6 fluorines, so sulfur again, only 1, so there's no mono shown. And then the 6 fluorines would be hexafluoride, so sulfur hexafluoride. And then finally, here's one where our first element does have more than 1, so it would be dinitrogen, showing I have 2 nitrogen, attached to 4 oxygen, which would be tetraoxide. And really this one should have the A drop because of the O in oxygen, so keeping that rule in mind that we talked about, getting rid of that A. All right, now, one important thing to keep in mind is that the prefix system cannot be used to name any type of ionic compounds. Only the stock system, or honors, also the classic system, can be used for ionic compounds. All right, so we're going to continue practicing this tomorrow in class a bunch and be able to start going between names and formulas and vice versa. So you are all set.